Hello, this is question 15 on your June 2022 Pure 1 paper from edexcel. It's a modeling with differentiation. So you have a company that makes toys from children. Figure 5 shows the design of for a solid toy that looks like a piece of cheese. So it's this one here. They tell us a few things they are very clear in the figure. So you know the angles, you know the size, and the volume of the toy is 240. I wouldn't ignore this because we are going to use it. Show that the surface area of the toy S in centimeter square is given by this formula. If we find the surface area, we have two sectors, two rectangles, and this curvy thing here. So we are going to find each of them and add them all together. And it's going to be in terms of R and H. And our expression is only in terms of R. So I'm going to show you how we are going to eliminate H. So for A, we have the area, let's say, of the sector. I'm going to call it S. I have two sectors, and the area of a sector when I have radians, remember, is just going to be 1/2 of the angle in radians times radius square. So 1/2 the angle in radius, so 1/2 angle in radius, which is 0.8, and radius squared. We can cancel this with this, and we have 0.8 r squared is our two sectors. Then these two rectangles here are h times r, and I have one here and one at the back, so 2 times hr. So the area of the rectangles is 2 times hr, so 2hr. And then I have that curvy thing, so I'm going to write C. But you see it's going to be a rectangle. This is H, and this is going to be the arc of this sector. The arc when the angle is in radians is just R times the angle, so 0.8 R times H. And I have only one of those, so it's going to be H times the arc, which is R theta, which is 0.8. So I have 0.8 HR. So my total surface area is going to be 0.8 r squared. So I'm just adding these three together, and then this plus this is 2.8 hr plus 2.8 hr. But I don't want h in my expression, so I don't have h in my expression. What I'm going to do is to use this line to give me a relation between h and r and eliminate h. So the volume of the toy, this is like a pism, so I have the area of the base times the height. The area of the base is the area of the sector, which is, again, so the volume is going to be area of the sector, which is the angle times 1/2 times radius squared times the height. So this is the area of the sector times the height, and which means, and this is 240, they tell me. So this means that I have 0.4 r squared h is going to be 240. So h is going to be 240 divided by 0.4 is 600 divided by r squared. And I can go to the formula that I had before and substitute h by that expression. So here I can substitute this expression. So my surface area is going to be 0.8 r squared, 0.8 r squared plus 2.8 times 600 r squared times r, what was that? R, yeah, and this is going to be 0.8 r squared plus 1680, and I'm going to cancel this r with the square, so divided by r, and this is the expression that I have to show. Yeah, so it's this one here that is given, this one. And then using algebraic differentiation, find the value of r for which s has a stationary point. So s, this expression here, is going to have a stationary point when the derivative is 0. So what I'm going to do is derivate this expression and make that equal to 0. So So ds by dr, which is the only parameter that has, is 2 times 0.8, which is 1.6, r to 1 less. And then this is the same than having r minus 1. Yeah, so this divided by r is r minus 1. So the derivative is going to be minus 1680 r to the power of minus 2. Yeah, you can write that way, or the r in the denominator. And this must be equal to 0. I think it's easier if we write r in the denominator to solve the equation r squared. I think you are going to see it better. This is going to be 0, so what I'm going to do is multiply by r squared. So I have 1.6 r cubed minus 1680 is 0, which means that r cubed is going to be 1680 by 1.6, which is 1050. I do the cube root, and I have 10.16 is centimeters. I don't think they'll tell me. Centimeters, h is in centimeters, so this will be centimeters. Centimeters to 2 decimal places. This is a stationary point. I don't know yet if it's a maximum or a minimum, but I know it's a stationary point. And then for C, they say prove by further differentiation that this value of r gives the minimum surface area of the toy. So I need to prove that it's a minimum. Remember, I need to find the second derivative, so derivate again. And if it's positive, it's going to be a minimum. So second derivative, just using this expression, is 1.6. And again, this is r minus 2. So I have minus 2 at the front. Together with this minus becomes a plus. 1680 times 2 is 3360 times r to the power of minus 3, or r cubed. When I substitute my value of r, which is positive, everything is positive, so the whole thing is going to be positive, even without finding the answer, the number, which means it's a minimum. Yeah, remember, if the second derivative is positive, it's a minimum. And this is all with this question. It's quite typical. So with this differentiation, modeling with differentiation, you always have a volume or a surface. They are going to give you a clue or something to eliminate one of the parameters, and then you can differentiate with respect to the other to find maximum, minimums, and things like that. Yeah, but that's all.